So what we're looking at is a piecewise function. There's the green piece over here, and then there's the red piece kind of over here. One thing you would need to do is you need to kind of divide the domain up a little bit. You notice this part has the values for x that are smaller than or equal to 0. How do I know it equals 0 is because the solid dot here, and then it's everything kind of on this side of things. The domain is the x values. The other one will then be x would have to be greater than 0. So in other words, you can see the empty dot here, which means it's not equal to 0, but it is everything to the right of 0, which is all the positive stuff. So that's part of the decision making. The other part is to come up with the physical equation for this. Now, an equation, we need y equals mx plus b. And in this case, let's take a look at our slope here. It's a rise of 1 and a run of 2. So our slope would be 1/2 x. And then we need the intercept, which happens to be basically nicely provided for us right here. There's your intercept at -3. So this would be the function for the values where x is less than or equal to 0. The second guy, we need to also create its equation. We are looking for y equals mx plus b as well. The slope, I'm going to just pick 2 points that are easy to record. That's a down 1 and over 3, so that's a negative 1/3 x as a slope. And also its intercept is quite easy to find there at +2. And so this would be the equation for the values of x that are greater than 0. To see the 2 parts there is you have to record the physical function. There's the physical function. And then you record its domain. This part's its domain. And then, again, I'm going to record the physical function, and then as well its domain. The key to finding the equation or the function is to use y equals mx plus b. Let me do one more of these. All right, let's first talk domains here. This guy kind of goes all the way up to here. And then this guy starts there and goes the rest of the way. So this looks like the values for x that are smaller than +2, right? Because +2 is up to this point. And the reason I said that they are smaller than 2 is because it's got the open dot. The other one must be the values that are greater than or equal to 2. Because again, it's starting from this 2 line, this x equals 2, and then beginning to move. So those are the domains. Now, let's go through finding the equations. The equations, again, follow y equals mx plus b. And so I need a slope. So let me find 2 points that are easy to find. This one's pretty easy, and then that one. So it has a rise of 3 and a run of 1. So that's just a slope of 3x, and then its intercept is right here, nice, easy to find at -5. And so this would be the first piece of the piecewise. Now the second one I'm going to say is a little more challenging. Let me tell you why it's a little more challenging. The slope isn't that hard to find. Let's find the slope. Looks like a rise of 2 and a run of 1. So the slope is 2. But the x-intercept is tricky, so I'm going to kind of extend this following the slope and if I was extending this, I would follow and hit at 2. So sometimes you need to extend the line a little bit to help you obtain the full equation there. So let me just walk you through that tricky little maneuver there. I knew the slope was a 2, rise of 1, run of 2, but I didn't know where to hit the line. So what I basically did is I continued that line over 1 down 2 over 1 down 2, and that's how I was able to find its intercept. And then this becomes the piecewise function.